Let's talk about combining like terms. This is a very basic, this is maybe the most basic algebra skill or process, but everything else in algebra really builds on combining like terms and distribution. These are some of the most foundational and basic skills. So I want to spend a little bit of time talking about them, making sure that we have a good understanding of them, so that when we move on to more complicated things, we have a good foundation that we're building on. So this is a very simple process, but I want to take a little bit of time to really explain it well, so that you have a good understanding of what's happening when we're combining like terms. So first, we need to ask the question, what is a term? When we're talking about combining like terms, what do we mean? What do we mean by a term? And a term can be three things, one of three things. It can be a number by itself, like 3. It can also be a variable by itself, like n. Or a term can be a variable with a coefficient, like 3n. When I say coefficient, I mean that number in front of the variable, the 3 in front of n. And we're considering that one term, because when I have two things like that are jammed together without any operation, notice there's no multiplication sign, even though it's implied. When I have two things jammed together like that, I'm going to treat it like one term. And terms are going to end up being sort of the building blocks, the atoms and molecules that we're working with as we start going into more complicated algebra processes. So the first thing I want to do is I just want to look at a couple expressions and just count the terms. How many terms do you see in these expressions? So the first one, 3n plus 2, that's one expression. How many terms are in that expression? And the answer is 2. There are 2 terms here. The first one is 3n, and the second one is positive 2. Notice that plus sign, I've included that with 2 to signify that 2 is positive 2. And that will be more important, especially when that is a subtraction or a negative sign. I sometimes I'll have a negative term, and it's shown to be negative by a subtraction or a negative sign in front of it. Also notice that operation, that addition, sort of serves as a divider, a separator between the two terms. And when we start looking at longer expressions with 4, 5, 6 terms, those plus and minus signs are going to be really, really important. So keep an eye out for those, because they're going to be what separates one term from another. So this one is pretty simple. Let's look at one that's a little bit longer. How many terms do you see in this expression? And it's 4 minus 5x plus 3y squared plus 7x squared y. So how many terms do you see here? So first off, we have 4. 4 is one term by itself. The next term we have is negative 5x. Again, notice that subtraction sign. I'm bundling it together with 5x, and it becomes negative 5x. The term itself is negative. And then I have 3y squared, or positive 3y squared, and 7x squared y. So I have 4 terms here. And the terms are separated by operations, addition and subtraction. Notice that when I'm bundling these terms together, when I'm separating these terms and identifying them, I'm including exponents. I'm including, even if it has more than one variable, like 7x squared y, that's all one term. A term can have more than one variable. So sometimes a term can be very long, but essentially a term here is it's a number, it's a variable, it's a coefficient with a variable, and they're separated by those operations, addition and subtraction specifically. So this expression has 4 terms. So once I have identified terms, once I can count the number of terms in an expression, I'm ready to start combining like terms. So the second question I need to ask is, what do I mean by like terms? What are like terms? What makes 2 terms like? And it's 2 things. First, the terms are going to have the same variable, and then the terms are going to have the same exponent. So both of those requirements need to be met in order for the terms to be considered like, and for me to be able to combine them. So let's look at some examples of this. I'm going to show you an expression, and I want you to not just count the terms, but I want you to look and think what terms are like here. What terms have the same variable and the same exponent? So here's our expression: 7x plus 3 minus 4x plus y. So here, my first term is 7x. And the question I want to ask is, are there any terms like 7x? Are there any terms that have the same variable and exponent as 7x? And the answer is yes, negative 4x. And again, I'm including that minus sign. It becomes negative 4x. So those two terms, because they have the same variable and same exponent, are like terms. Then I have positive 3. Is there any term like positive 3? And the answer is no, because 3 doesn't have a variable with it. And all of the other terms have variables. 7x and negative 4x, those are already taken. Y, that's just a variable by itself. So 3 actually is going to be by itself. And then similarly, we only have one term remaining, y. That's also going to be a term by itself. So there's nothing like 3. There's nothing like y here, but 7x and negative 4x are like. So if I was going to be combining like terms here, I could combine 7x and negative 4x. And we'll talk more about that on the next slide. So here I want you to not just identify like terms, but let's go ahead and practice combining them. So once I see two terms that are like, let's try combining them. And again, I'm going to start with the first term on the left, which is 5y. So reading this expression, 5y minus 4x plus 2x minus y, what other terms do you see that are like y, that have the same variable and same exponent? And there's one other term, which is at the very end, negative y. So when I'm combining these two terms, I'm going to be keeping the variable and the exponent the same, and I'm just going to be adding and subtracting the coefficient. So 5y minus y is going to end up being 4y. And then I also have negative 4x and positive 2x. Those are also like terms. Negative 4x, positive 2x. When I'm combining them, I'm going to be adding or subtracting the coefficients, those numbers in front of the variables. Negative 4 and positive 2 gives me negative 2. So when I combine like terms here, when I simplify this expression, I end up with 4y minus 2x. 5y and negative y gives me positive 4y. Negative 4x and positive 2x gives me negative 2x. Now, I want to point out, negative y doesn't appear to have a coefficient. There's no number in front of y. But there is an assumed 1. There's sort of this invisible 1 in front of y. Anytime you have a variable by itself without a coefficient, you can assume that there is a 1 there. So this is actually 5y minus 1y. Here, once I've simplified it, notice that I've gone from 4 terms down to 2 terms. And that's the process that we're actually doing. It's called simplifying expressions. Let's look at one more example together. This is going to be more complicated, but we can do it together. Here's our expression. 2n squared plus 7n minus n to the third minus 3n squared plus 4n to the third. So right there, I have 5 terms. And notice with those 5 terms, they all have the same variable. So my question is, can I combine all 5 of these terms? And the answer is no, I cannot, because although they have the same variable, they do not have the same exponent. So when I'm looking for like terms here, I really need to notice the exponents and only combine those terms that have the same exponent. So let's start with the one on the far left, 2n squared. What term is like 2n squared? 7n, same variable but different exponent. Negative n to the third, same variable, different exponent. Negative 3n squared. So there I have n squared again. Those are like terms. I can combine those like terms. What about 7n? Is there any term like 7n? And the answer is no, because all of the remaining terms have exponents, and 7n doesn't have a visible exponent. And then my last two, negative n to the third is like positive 4n to the third. So even though these all have the same variable, I can't actually combine them all together because they have different exponents. So when I'm combining them, I have to look at the exponents and combine like with like. So let's start with 2n squared and negative 3n squared. So again, I'm not going to touch the variable. I'm not going to touch the exponent. Those are going to stay the same. I'm only going to add and subtract the coefficients. So 2 minus 3 is going to give me negative 1. 7n is going to stay 7n, and then negative n to the third, positive 4n. Again, that's like a negative 1 and positive 4. That gives me positive 3. So when I combine the like terms here, I get negative n squared plus 7n plus 3n to the third. And notice when I added n squared and n squared, I didn't make it into the fourth. I didn't change the exponent. Adding and subtracting is not strong enough to change exponents. The only way that I can change an exponent is with multiplication or division, and I'm not doing that right now. I'm really only adding and subtracting. So the exponents are not changing. Again, negative n to the third and positive 4n to the third. The exponent stays 3. It stays to the third. So that's a mistake that I see students make really frequently. You know, they'll do 2n to this 2n squared minus 3n squared, and that becomes, you know, n to the fourth. Or, you know, they'll have two n's and they'll combine them, and that becomes n squared. And then they'll think, well, I can combine this n squared with this n squared. And it gets really complicated. But it's not. Keep your variables. Don't change your variables when you're adding and subtracting, because adding and subtracting, like I said, are not strong enough to actually make that happen. And there's one more thing I'm going to add here, which is that there is a sort of more conventional, a more polite or accepted way of writing this expression, negative n squared plus 7n plus 3n to the third, which is like this, 3n to the third minus n squared plus 7n. All I did was rearrange the terms. Notice that negative n squared stayed negative. Positive 7n stayed positive. I rearranged these terms, and like I said, this is more conventional or more accepted in order of descending exponents. So starting with the highest exponent and then moving down, exponent of 3, exponent of 2, exponent of 1. This is not. It's not a matter of right and wrong. It's more common, it's more conventional to write it in that second order. So if you're taking, you know, a GED test or something like that, and you have a multiple choice option, be aware that the terms may be written in a different order than you had them initially, and they can be rearranged. And more often than not, they're going to be arranged in order of descending exponent like that. So that's just kind of another little note here at the end. I hope that this video has been helpful. If you have any questions, if you want me to explain something else in more detail, or if I said anything wrong, please let me know. And I'd be happy to correct my mistakes or make an additional video to answer whatever questions you guys have. Thank you so much for watching.